Today's session is holistic approach to implement Six Sigma quality in chemical chemistry is about the analytical part. So processes are one, and the other one is the analytical. So in analytical, so most of the steps are involved from the analyzer. However, these are interlinked. Suppose an analyzer has sample aspiration requirement of much higher, then samples which have less sample volume, they may have short sample times. And that will be counted as pretty analytical, but read by NL. Similarly, some other factors like dilution. So if your analyzers or reagents linearity is not optimized or not wide enough, then you may end up doing many more dilutions for the parameters which have exceeded the linearity. So in those situations, you will end up doing much dilutions and they are prone to errors. So analyzers involvement is very high in day-to-day practice in controlling errors. So that's why I thought of taking this. So secondly, I would like to thank the organizers for giving this opportunity here. So I'll start with some introduction to Six Sigma. However, the history of quality is about century. Like in 1930, first the sugar called assessing the quality was introduced in industry. Afterwards, there have been many more evaluations in quality assurance, like LJ like Davis, and then analytical errors, and then this is the fifth or sixth generation which we are talking about, Six Sigma. So Six Sigma, it was introduced by Bill Smith in 1986, and he was an engineer and used to work with Parel. So he thought of doing some statistical analysis for reducing the errors. Later, it was incorporated by industries like Honeywell, General Electric, and they were able to save a significant amount of cost to their organization by implementing Six Sigma. And later, it was also incorporated by many more big organizations. Those were rated one of the Fortune 500 companies. So 2/3 of those organizations have adopted this concept of Six Sigma and found that useful to reduce the errors and saving cost as well. Then later in 2000 onwards, it was incorporated by healthcare as well. So in 2011, ISO has published a document which is called ISO 13053 2011 version on Six Sigma process, that is statistical analysis. So nowadays it is widely used in healthcare and found to be very useful. So I hope many of you would have heard of Six Sigma. So just would like to ask a question that how do you use Six Sigma and Six Sigma matrices in your lesson? Why do you? Any question? Maybe you can think in your mind and then you can correlate with the survey results which I am going to see here. So Dr. Westcott has done one survey in 2018 and found that these are the survey results out of 604 labs who have responded to the survey. And there were multiple choices allowed. So you can see the highest survey answer is like to assess current the performance of the lab. They want to Six Sigma. And then afterwards, so you can see like reduce the number of rules, QC rules I'm talking about, and they reduce control repeats. And even at the bottom, you can see to select the instrument purchase decision, and they were used to assess the performance of Six Sigma there, and many others like reducing troubleshootings and reducing technical support, I mean the troubleshooting the breakdowns, and reducing outlier, reducing control repeats, etc. So there are so many. So these are the the aspects for which laboratories would like to incorporate Six Sigma there. So now, typically, so these are the lab's objective to incorporate any quality system in their lab, like to reduce the medical errors and eventually, to have minimal legal implications, and also the reputation of these institutions. Then decrease rerun and reworks, and to reduce the cost of operation. And we'll see in following slides how we can reduce the cost of operation. And optimize QC rules. So we'll see how we can optimize the QC rules. And the looking at QCs and day-to-day practice can be cumbersome if you try to incorporate all the rules like monitoring the trend, monitoring the bias, monitoring decision, etc. for each and every element, and that to each and every label, right? So we'll see how we can simplify this with Six Sigma. Then increase customer satisfaction. Eventually, when you reduce errors, you tend to have better quality results and better accuracy. So you can increase the customer satisfaction as well, and to reduce the turnaround time of how important test result to the lab. We say that one tube means one life. So if the result is too late for the patient or for the clinicians, then it has no value. Okay. So we will see that. Now, as one of the requirement for Six Sigma is having to assess the performance of instrument. So we'll see how we can assess that. But there is one disclaimer. So this is Six Sigma is one of the quality tools. It's not replacing the manufacturer or the validation you call or performance verification or IQ, whatever term you use in your lab. So in industry term, it is called performance verification of the parameter or instrument. It's a generic word. So that we do at the time of installing instrument or at the time of installing parameter or assay. So that includes dynamic range or AMR and sensitivity check and method comparison and the precision as well. So these are the figures which have been done during the performance verification or performance evaluation. So this Six Sigma doesn't replace that process. That has to be done. So Six Sigma is one of the additional tools or optional tools which you can incorporate in to have these uses. So now we talk about Sigma matrices and DPMO. DPMO is nothing but defects per million opportunities. Defects means you can consider as error. So error per million. And the quality standard achieves. How we can translate that into the quality standard of that particular product, analyzer, or parameter. So here you can see in this table on the left hand side, sigma matrix. So that you must have heard of 6 sigma, 5 sigma, 4 sigma, 3 sigma, and less. Then the second is translates to corresponding effect per million. Let's say, for example, 6 sigma we call. So that means 3.4 errors per million. You may likely to have 3.4 errors per million of sample size. That means approximately 1 error per 400,000 samples of events. That's the quality we are talking. Then when you come down, so lower the sigma, higher the likelihood of having errors. Higher the sigma value, lower the likelihood of having errors. Then it translates into quality standard achieved. So when we talk about sigma, that means 99.999% of quality standards we are talking. Generally in the industry, so more than 3 sigma is acceptable. More than 6 sigma is good. Less than 3 is, it needs improvement. Then how we can use sigma matrices into this sigma matrices which we are talking about 1, 2, 3, 4, 5, 6. So how we can use these sigma matrices into quality control or optimizing QC. So in clinical laboratories, determination of these sigma matrix or assay or instrument provides a qualitative assessment of instrument. So we can say this parameter performs more than 6 sigma, more than 3 sigma, and so on. Also, it can be used to design optimal quality control schemes for individual assays or group of assays or profiles or analysis. So how do we do that? So you must have heard of Westgard rules. At the bottom, I have provided the resources as well, and in the last slide, I have collected all the references which I have taken from. So you might have heard of Westgard Sigma rules. So in standard Westgard Sigma rules, there is something different. So you will see 2S in that rule as well, and you will not see the sigma mapping at the bottom in the standard rule. In recent years, I think in 2015, Dr. Westgard has incorporated 6 sigma into quality control rules. So that means if your assay is performing at 6 sigma, you may consider only one, that is 1,3S. I hope you understand what 3S means. 1. If we conceive more than 3S, then only you have to take X. Otherwise, you can release the results. So I will just share the simplified version of these rules. So let's say your assay is performing at 6 sigma. So if you are running 2 levels of control, then if one run exceeds 1,3S, then only you take action and value. That means with 6 sigma performance, you can only use 1,3S rule. If your sigma value is low, or let's say 5 here or 4, then you may have to incorporate more number of rules because that is not performing at gold standard or optimal. So that way you can use this set of rules here. So every QC rule can be associated to a single value, single sigma matrix, and optimal QC rule is defined as a rule with sigma value closest to it. Okay. So next survey, there are many sections in this survey which was conducted by Oscar in 2018 regarding the Six Sigma. So I have taken two sections which I have shared earlier, one of which I have shared earlier. And the other one is what obstacle prevent you from using applying Six Sigma and Sigma matrices. So what do you think? Have you thought of Six Sigma and have you thought of applying it and incorporating it? And what was preventing it? What hurdles you facing? Just think about it and you can correlate with this survey results. So 256 labs have responded to this survey and there were multiple choices there. So you can see the most of, like 60% people believe that there was lack of training or education towards Six Sigma. So that's why they might not implementing it or thinking of it. Then 45% people believe that there was no automated process for assessing Six Sigma. And then 31% people believe that lack of regulation or guidelines because there is no mandate around it. So then others are like lack of time, lack of manufacturer support. So and there are others causes there. Is it relating to the thinking or the thought of like this? So now, where do we start? So let's say we have understood the Six Sigma and we'll see how we can calculate this and what are the things we have to take care of. So when it comes into our mind of being Six Sigma and increasing our quality standards, the reputation of this institution, safety of results, etc., then first of all, you need to think of change. So change is not easy. So you might have heard of Kubler-Ross change curve, right? So that explains how change can make a difference, but there are some challenges, right? So in first phase, so there will be shock. I mean, people will be reluctant to adopt that change, and eventually there will be some frustrations, depressions to adopt that change, right? And then once you have adopted that and made it as mandate, then people start experiencing it and the decision is taken and then it integrates. So this is how you can see the curve here, but you have to play a role in it, in each of these steps. So at the first stage, when we see the challenge, when the people are thinking, oh, what is this? What is this new thing that's come? You may be dealing with the extra efforts and extra success maybe. At that time, the creative alignment, so specific alignment with senior management also plays an important because you have to take consent from that. Why we need to do this process and what is the benefit we are getting out of it, etc. Then at the second stage, when people are facing frustrations or feeling like, oh, what is this and how do we do that, all that, then maximize communication. So, and the third stage, we have to spark motivation. So once you start seeing some change and two steps have been followed by the people, then you spark motivation that yes, it's making an impact. And then once people start adopting things, then you have to develop capability because at that phase, people will try to implement, but we may have some difficulty. and eventually then share knowledge and sustain it. So there is one here AIC model for implementing Lean Six Sigma. That is first stage, that is called define. So you have to define the problem first. So what area you are going to improve on, and then quantify it. So you have to analyze and measure and quantify at what stage it is. Then analyze the root cause of the problem, and then try to solve the root cause and sustain it. So that's the process goes for the Six Sigma. This is Lean Six Sigma. We are not talking about this whole thing today. So we are talking about the Six Sigma matrices. Right? So now, where do we start? So this is Six Sigma concept here, in which the relationship of imprecision, which is CV, and the bias, and the total error. So there is some calculation. This is the calculation, sigma value equal to your TA minus bias, which is divided by CV, the precision, and you get 6, which is very simple. So we'll see, but the elements here you see the TEA, where do you get that? What are the resources? How do you calculate? Yeah. So that becomes a hurdle sometimes. Then other thing is bias. However, bias we get very easily, but how do we get that calculation? And also the CV. Okay. So first we talk about precision, that is CV. So we may have questions like what we consider. Do we consider within run CV? Do we consider total CV? How many runs should we take into consideration? You know, so all these. So as you know, precision is a measure of random errors in sample size or subjects of measurements. Then, so you can take summarized data from routine QC over a period of time. CLSI document C24 A3 suggests 3 to 6 months data is represented by CLSI. Then the other way is you can determine the CV from utilizing 20 days protocol, in which you need to test control twice a day, minimum 2 hours difference you need to take, and that should be run for 20 days. So that is the other guideline. So by CLSI, that is PP 5 test 8. So according to these guidelines, you can perform the decision and get the CV. And the other way is, so these are two ways. The precision data should be generated but different in the line concentration. So that is important because your CV may be different at various levels of the template. Let's say for AST, if you perform the CV at minimum value of 7 or 10, so your CV will be different, and if you perform at 20 or 25, it will be different. But you need to consider the clinical decision points. So it should be within the range of that analysis. Mostly the performance claims on CVs have been suggested by manufacturers as well as validated. So this is how you can get one element of Six Sigma, that is CV or precision. Then bias. How do we determine bias in our lab? Incorporate this for calculating system. Okay. So as you know, bias is the systematic difference between the test result and the expected result. The result which has been generated and which it's supposed to be. So that's the difference we calculate for bias. So there are two forms of bias. One is the true and the other one is relative bias. So depending upon the expected results that is determined. So true bias can be determined if the expected result was generated either by the reference method reference method from the reference method. Okay? And also the bias can be determined from proficiency testing material, for which you generally get the Q value. And then the other one is relative bias. If all method means, like you have all methods, for that analyte, all methods have been analyzed, and you get bias out of it. So that is called relative bias. So relative bias also can be determined from a comparison study between two methods and two instruments, two reagent plots, etc. So this is how we get bias. So which is very simple. So expected value versus your test value, get bias. Then TEA. So this is very simple. So there has been a lot of things around TEA, so which I am sharing. I hope this will be the latest guidelines. So TEA is nothing but it is total allowable error. So you can call it, error limits as well, and which can determine your clinical significance for that parameter. So let's say if we have an analyte like glucose, so we say in one run my glucose value is 105, and the other run glucose value is 107. So is there a difference? How do you determine? How do you say that it's not a significant difference, or it is? For one person it can be significant, but other person it can be negative. So that is determined by T. So there are various ways we can get TA calculated. So the allowable error is a subjective component for sigma equation. So whatever sources you see, so not all parameters can be covered for TEA. So I'm sharing one guideline from international conferences. So in 1999, Stockholm consensus hierarchy and recent Milan consensus. So there are two different guidelines here. So the recent one is from Milan, which was developed in 2015. So provide a graded recommendation ranging from evaluation the effect of analytical performance on clinical outcomes. Okay. And in specified clinical settings, all based on current state of the art. So there are 3 to 4 guidelines here. So those have incorporated 3 models here. So what the model 1, in which total allowable error is based on the effect of analytical performance of clinical outcome. So if any of you are familiar with the HbA1c total allowable error, so earlier it was 10%, which was suggested by CNSI. But in recent guidelines, the allowable TEA for HbA1c is 6%, which is recommended by the TTDC guideline, which is diabetic. So that's the example of analytical performance on clinical outcome. The second model is total allowable error based on components of biological variation. Okay, so biological variation plays an important role in determining TA in second hierarchy. Then the third one is based on state of art. So state of art is recommended by many PT providers. PT means proficiency testing. Then the sources. So you can find readily available TAs available from sources. So like we commonly use sources are clear specifications, so CLSI, but you will find those TEAs are achievable but not desirable. The desirable means those can be very wide and easily achievable, but may not be desirable by clinicians. So then second source you can find from Lilibet. This is German quality assurance guidelines. Then the third one is RICOS, and the fourth one is RCP. So these are four commonly available resources. There are many more like data innovation. There are this, but these are four commonly resources available for obtaining TAs. You can develop within your lab as well. So there are certain guidelines which you can develop TAs in your lab. So we have got CV, we have got bias, and we have got total allowable level. Okay. But sometimes, if you do not use these TAs judiciously, so the data, the outcome you get out of it, it can be misleading. So there are certain documents available. So you may have to choose depending upon your lab's requirement, your clinician's requirement, and your own judgment sometimes. So some important considerations. There is no unified protocol that is defined for determining reproducibility or bias or for the sigma study. Then different publications or studies say different protocols, and eventually you get different sigma matrices. So lack of unified protocols leads to uncertainty in interpretation of published sigma matrices or various assays which may have different outcomes, and this can display your sigma values or equality standards we are talking about. So simple. So how do we get out of it? So some people say that is there any tool available, or is there any online software available, or is there any offline software available? So it can be calculated simply in your Excel sheet, or will be calculated there. So we see the calculation that getting sigma value for like TEA minus bias divided by percent CV. So all values are in percent. So here you can see in column A, this is the analyte name or parameter name. And in second column, level 1, level 2, and you can incorporate level 3 as well, if you have. And then column C, what resources we are using. So as we were talking about, there are different resources for different parameters. And then TEA from that respective source, and bias, what bias you are getting for different analytes and different agents, and the concentration, which concentration at you are measuring that bias of that CV, and finally the CV. Last column you achieve sigma value from this calculation. So here you can determine what are your parameters. For one single parameter, there may be one level you are achieving more than 6 sigma, and other level is even less than 6. Accordingly, you can decide your plan of action. So maybe in first go, you may not have all parameters achieving more than 6 sigma, or maybe even more than 3 sigma. Okay. So once you achieve this, then you can determine what are the parameters you need to take extra care, or for which parameters you can reduce the number of QC, which will eventually save cost. And what are the parameters you will need, maybe more maintenance or some other topic for each slides. Right. Now I am sharing some case studies, the white papers published around Six Sigma. So this is backend-footed white paper. And most of the section in this presentation I have taken from this white paper only. So this is very comprehensive document of 2 pages only. By reading it, you can easily understand the aspects of Six Sigma. And so in this study, there were 24 clinical chemistry assays which were assessed for Six Sigma. The instrument was computer PE analyzer. So the TEA were derived from PR, event, and RCTA respectively. And the precision and bias measured from between method comparison studies and the validation data. So targeted medical decision enables each assay. So that's what was considered. So in this study, we observed that out of 24, 21 assays had performed in 6 sigma metrics, and 1 assay was less than 5 sigma, and 2 assays were less than 3 sigma. So in another study, so this was published in association with College of American Pathologists. So you can find this article in Care Today. So it was Rock Regional Medical Center, RRMC. So they assessed 22 clear regulated general chemistry assays in AU 5800 series. And they utilized external QC techniques using 2 levels of QC material from Biochemistry. And basis this, they determined each assay bias in CV. These data were accumulated over 4 months, yielding more than 100 data points for each assay. And compared with peer group exceeding 100 laboratories. And they have used clear defined TBAs to obtain sigma matrices. So out of 22 parameters, they have found that 15 assays were performing at 6 sigma or more than 6 sigma. And there were 5 assays they were performing at 5 sigma, and 1 assay was at 4 sigma and 3 sigma. So this is the second study. There are many, and the other one is performed at Seth Medical Center in Korea. So they have calculated sigma matrices from DXC 700E. Regions are getting deteriorated and not performing efficiently. And or maybe the reagents have some carryovers. So we'll see in following slide what are the potential interferences that may be observed in reagents. Then you have standardized processes. So how many processes you have? So the study we are talking about processes, SOPs, and following those protocols. So that is also important. Let's say the connection frequency for certain parameters are decided at like, let's say 15 days once in 15 days once in a month. if those calibrations are not being done as required. So your calibration is a result of drift in your analyzer components, or maybe the reagent interpretation. These are two main factors. So how do we calibrate? So we use some standard material. We tell instrument that its value is 100, for example. So give me a value of 100. Over a period of time, your analysis component may be getting deteriorated. Maybe the optics is not performing at. So we adjust that those differences to get the desired value. So calibration is important. And calibrated material is important. With calibrated material, we are looking whether those values have got traceability to certain, authorized bodies. Then operator competency is very important again. So operator is the one who is driving all these things. Like Seth was talking yesterday that I would love to audit technician rather than the consultant. Because those are the people who are performing those assays and they know each and everything in and out of the instruments in which we are getting these analytes done. So competency to perform to calibrations, competency to perform the maintenances, competency to perform the dilutions, all that matters. Then sample quality, get garbage in garbage out. If the sample quality is, we can ensure the quality of results and the maintenance of the elements. So in the market, so there are many analyzers available. So the maintenance time can vary, and maintenance steps can vary, and the manual intervention can vary. So all these components should be taken into consideration because performing maintenance is manual. So the person who is running that instrument that may not be consistent with these maintenance processes. Suppose today maintenance which is taking an hour, so I have been doing it for many years. So I may find some shortcuts. I may not be consistent over the years to perform the same maintenance. So consider the maintenance steps and time. That's why one of the elements you have seen in the survey results that 6 sigma performance of analyzer or parameters is considered to the purchase decision was made. So all these aspects we need to take care of. So I was talking about the reagent. So in general, we see that especially in government, so the analyzers were purchased from a different manufacturer, and the reagents are used from different companies or different manufacturers. So it may be some mandated by some government bodies, but how it can impact our performance. So we know we develop our analyzer and we validate our assays according to our input. We have designed our assay formulations according to our analyzer specifications. So, and we have validated that. We validated that one parameter is not interfering with other parameters. How do these interfere parameters? The assay formulations are different. Like in many of the assays, the buffers are used. So generally, phosphate buffer is used. So maybe in creatinine, the phosphate buffer which was used, that is not impacting creatinine. So creatinine is performing well, but it may be impacting the phosphorus or any other element. And for preservative, the glycerol is used in many of the devices. Maybe that glycerol is impacting some lipid parameters. It may not be impacting the same parameter, but have you evaluated that it will, that interference? Yes. So answer is with you. So that's why I recommend either do the extensive validation for all the assays, or stick to the same manufacturer explains about the estimate performance and the reagent performance, particularly of these. So this takes me to the end of this presentation. So in summary, the sigma matrices, sigma metric analysis is only one of the tools in the larger laboratory quality control or QA program. Each sigma calculation can define the individual assay performance at one point of time. The clinical laboratory is the dynamic entity of the array of moving parts, as we have seen in the previous slide. So you may have to continually, it's not one time job. So you may set frequency like you assess the sigma performance, or maybe you can decide the time accordingly. So whatever matrices are used to guide the laboratory operations, they must remain monitored, which requires constant and careful consideration. And sigma matrices should be component of an overall holistic approach to quality in laboratory, which should include as a part of quality program and incorporating extensive QC tools available on IT medical platform. So you may have some other softwares like Unity or others. Ensuring skills of the training of operators. So it's in order to improve the performance of those assays which have not performed Six Sigma or more. So that is required. And performing instrument maintenance paid as recommended by the manufacturers. Adhering to the reagent and calibrator stability claims, so that is much important. And addressing particular pre-analytical sample handling issue that potentially impact the quality of the result. This is the summary. There are any questions I
see the percentage at different analyte concentrations.
Correct.
So we get different sigmas. One different sigma for different compounds. Bias percentage we take from equal. Generally we have equal, so we take from equal. But we have only one concentration of equal samples at that for that particular. So you say we need to take data for 3 to 6 months. How do we calculate bias? So for IQC we always have 2 levels. So like for IQC, we always have 2 levels. So, but one single equal sample has one single analyte concentration. So how do we calculate bias percentage over the time period of 3 months or 6 months?
So there are different recommendations. So suppose for one analyte or one concentration level, you are getting the bias, or maybe you are talking about bias, right?
Bias.
So for one analyte, you are obtaining the bias from equal material, and for other concentration level, you can incorporate any other source. So I have outlined there are different sources available for bias as well, PA and series array for all. So the first thing top of that table or that list is recommended. If that is not available, then you can go for the second.
So bias percentage. So let's say I am calculating sigma for 3 months. So I will have bias percentage of first month. I will have a separate bias for all 3 months. So can I take an average of all 3 months and apply it for both the concentrations?
So I think we will have to go to some guideline, but that is not recommended. So it is real time. So that's why I was saying it is a continuous process. So suppose the assays which we are performing better at last time, they may not be performing the next time.
Okay.
So that's why you have to calculate all these three things again. TA maybe you can use from some resources, but bias and CV have to be real time.
So, if we can take the average of all the months which we have to consider, like 3 months or a 6 months average for a bias also for the CV also.
So, like in one of the guidelines, it was saying over a period of 4 months or 6 months. So you can take that, but it should not be changing significantly. Suppose if you are getting the CV of 2.5 for certain analyte over a period of last 6 months, if it has gone to 5, so you have to identify the root cause. But otherwise, you can take an average. Suppose if it is coming as 2.8 this time, so it is manageable.
Yeah, for
It should not change significantly.
Yeah, so at this point, so if the sigma is on your lower side, then you can go on a map, website of the months to check which of the months CV was high or the bias was not appropriate with respect to other months. So if we can exclude that and again we can calculate, we can correct that and we can calculate the sigma. Is this the right system to calculate sigma?
Actually, we should not manipulate. Whatever we are getting is so that
we can-
as a result of something.
Yeah, but we come to know if that particular month is affected to calculate the sigma. So we can improvise, like if the first assuming your CV percentage, if you go on higher side, so obviously we will not get the sigma in the range, or like a good sigma. So you have to look after to maintain your CV percentage or the
You have to find the root cause.
root cause. Yeah, so like how will we maintain the CV is like finding out the root cause to maintain your edges or the CV percentage.
Yeah, let's say you are moving was performing at more than 6 sigma last time when you were evaluated. This time it has come down less than 3 sigma. So you have to document it that yes, it was performing.
Yes,
well.
that will be a part of our root cause analysis.
Yes, good cause analysis.
Yes.
That is continuous.
Excuse me. Sir, as you said, we have to calculate sigma every month or
Yeah, I mean there is
then otherwise,
no clear guideline that you have to do almost.
so we will have only one CV reading and one bias reading, or we can take the higher bias reading to be more cautious rather than taking the average. We can take a higher of the 3 months so that we are more cautious about that.
Yes.
We may have some false rejections because of that, but on overall to be cautious, we can take the higher among the three if we are calculating for 3 months. Okay.
So with regards to frequency, there is no clear guideline. So you can see at what time our calibration frequencies are. Like if your calibration frequencies are most of the parameters is monthly basis, or maybe your agent changing the agent frequency is on monthly basis, you can determine on monthly basis. Similarly for PT material, QC material, or other things, you can take those elements into consideration, which can impact these elements of safety. So accordingly, you can decide your frequency. Maybe initially days your frequency can be too frequent. Then later you can widen it. That way you can set the frequency.
And how to calculate using the SC? If,
The errors are given in STs. So how to calculate sigma in that case?
Earlier, actually, it was called TAE instead of TEA. So that was using C, but there were some flaws into it. So that's why they have incorporated the recent TEA.
Generally for airframes, they are giving in STs only. Like there is no percentage allowable errors given. You've seen many guidelines.
These are available.
You are using CV% to divide that.
Yeah.
So we use 7%, but the total allowable errors are given in STs. So how to calculate using that ST?
But allowable errors are in percentage.
So maybe there are some other guidelines for it.
There was one old guideline in which TAE was calculated out of S. That is no longer.
So I want to know about what is the impact of QGA. Actually, whenever sigma comes less than 3, we calculate quality goal index, like bias by 1.5 into CV. So when it has a criteria less than 0.8, we need to work on inaccuracy. More than 1.2, we need to work on imprecision. So there is a guideline by Mr. which says that whenever sigma is less than 3, we need to narrow down where we need to work on, whether it inaccuracy or imprecision. My doubt is in what way is there a difference in troubleshooting inaccuracy and imprecision? So I don't have a clarity. Like, what is it?
To be honest, sir, I'm not familiar with the guideline you are talking about, the quality index. I'm not familiar with that, but you have to get to the root cause, whichever is impacting, like out of these three elements, PEA is from resources, then the remaining two, like CV and the bias. So any of these could have violated, and you have to find the root cause. The guideline you are talking about.
So one more doubt what I have is, let's say we are performing root cause analysis based on sigma performance. So it actually includes the imprecision and inaccuracy associated with the process.
With relate to QC mode. Because there are other factors also. Suppose for QC, you are consciously doing like you are using certain amount of volume which you have decided, and you are making a report. So it is well sufficient for the quality control. But if you are not using the optimal sample volume for samples, so maybe the short sample, due to the short sample, some of the results could have impacted or the patients. So it is not covering the patient samples. However, our quality controls we are doing because of ensuring the safety of our results only. But the metrics we are using, that is related to QC number, quality controls. So for that, there are some other guidelines like you should use your moving averages as well. So there are some advanced tools available, so which we are covering today.
So if we are troubleshooting based on sigma performance, does it replace equals troubleshooting?
As I said earlier, so this is one of the tools and options. So we are not going to replace any methodologies in the QC programs. Only the way you can optimize your QC rules. QC rules. We are not replacing IQC, we are not replacing equals.
Thank you so much.